Hello, we are going to go through the next topic in Algebra 2, which is inequalities. So the beginning of Chapter 1 focuses on expressions, which don't have any equal sign, less than sign, just variables, numbers, operations. And then we did equations, which are things that have equal signs. And now we're getting to inequalities. So we have inequalities that you should be used to. You should be used to less than, greater than, less than or equal to, greater than or equal to. Not equal to is also considered an inequality. So we're going to kind of go through just like from words to symbols. We're going to talk about how to solve them, how to draw them. Hopefully everything here you learned in Algebra 1, and this is just a refresher. So first, if it says x is greater than 4, greater than sign, making sure you know what sign's what. The greater than sign looks like that. So that's how we would write x is greater than 4. What we do for graphing, and my number line graphics are not going to be really fancy. On Delta Math, they can actually ask you to draw a number line graph as well, and they're not super fancy. All I really need to see on the number line is I need to see that number 4, in this case, greater than 4, whatever number that is, kind of like that starting number. You need to decide what type of circle, and it's going to actually give you that option in Delta Math, open or close, to put on 4. If it has a greater than or a less than, and it is not in equal to, you want to do what's called an open circle. What that means is we're not counting 4 as the number. Then we need to make sure we draw an arrow, and this is also something you can do on Delta Math. It'll ask you if you want to switch the direction the arrow is going. Anything greater than 4 is this direction. Those are all the values that are greater than 4. I don't know why it keeps switching on me. If it says greater than or equal to, the only difference symbolically is you have the little line under the greater than sign. The difference when it comes to writing is you're going to have your closed circle. What that is saying is 4 actually is included. 4 is equal to itself. And then your arrow, again, heading in to the values that are bigger than 4. So those are greater than 4 or greater than or equal to 4. And I'm just using 4 as kind of a random example, random number. If it's less than, I'm just going to move both of these at the same time. You have to look and see if it says less than or equal to. You're going to graph them very similar. Less than is going to be an open circle because it does not include the 4. Less than or equal to is going to be a closed circle because 4 is included. And then the arrow should head in the direction of the numbers that are smaller than 4. So heading this way, heading this way. If you have something that kind of has more than just a single verb, so it's not is less than, you have something like this, 5 fewer than a number as is at least 12. Fewer than a number means you're subtracting. So 5 fewer than a number. We're just going to be real generic with our number and call it x. The word at least, if I said you want to find a summer job and you want to make at least $12 an hour, what that means is you want to make that much or more. So the wording at least is going to be greater than or equal to. You may also see something that says like no more than. If it says no more than, it's going to be less than or equal to. You're trying to keep something under a certain value. To solve this one, and we're going to kind of get into this in a second, but it's a little preview here, we're going to need to get x by itself. So we're going to add 5 to both sides, which means you're going to end up with x greater than or equal to 17. So that means on my number line, 17 is my number that it's kind of my dividing number. We want greater than or equal to, so we're going to include 17, and it's everything bigger than that. So that tells me that any number in there, if I picked like 25, if I take 5 off of 25, I'm still going to get something that's at least 12 or more. As far as our properties, and most of these properties I'm going to go through really quickly. I'm really only going to spend time at the end here. Transitive property, kind of like the transitive property for equations. If A is bigger than B and B is bigger than C, then A is bigger than C. So, and you can even think it in real life. If Joe is taller than Rebecca and Rebecca is taller than Sam, then that means Joe is taller than Sam. It kind of has that connecting piece to it. Not going to go through much of an example, but just the idea that we can connect pieces with it. The idea is this B, this middle value is the connector between the two. Addition and subtraction, you do this a lot. Not going to talk too much about this one. Anything I do to an inequality as far as adding or subtracting, I have to do it on both sides. So for example, if I have x minus 2 is less than 5, I am allowed to add 2 on the right as long as I add 2 on the left. Again, keeping that, in this case, not necessarily a balance, but keeping that like inequality relationship. The last two I do want to talk about a little bit, and it's hopefully something you remember from Algebra 1, and it's going to look really crazy the way I write it. When I am multiplying both sides of an inequality or dividing both sides of an equality by something, it really depends on what I'm multiplying or dividing by, if anything changes. If I multiply both sides by something positive, so if I have a 1/2, just to show you an example here, if I have 1/2 x is greater than 6, and I want to get x by itself, I would multiply both sides by the reciprocal. Nothing else changes. I still have an x, I still have a greater than, and now I get 12. However, if you are multiplying or dividing by something that is negative, so if I multiply both sides by a -2, if I divide both sides by a -5, you have to flip the inequality. So for example, if I have an inequality that is -3x less than or equal to 12, and I'm asking you to solve that inequality, I need to get x by itself. Right now it's being multiplied by -3, so I need to do the inverse. I need to divide by -3. As soon as you do that, as soon as you divide by a negative number, it will flip the inequality sign. So this entire inequality will flip backwards. So instead of less than or equal to, it's going to be greater than or equal to. And then you get a -4. So that is something definitely to kind of make a note of. If you divide or if you multiply by a negative, flip the sign. And it is so easy to forget. You'll be working on Delta math problems. You'll be working on homework problems. I've forgot it in the middle of the notes. And the reason is when you do that, it impacts that inequality sign. And if you don't flip it, then you're going to get something that is not a true inequality, that would not make the original true when you look at your final answer. So what we're going to do is we're going to go through some basic ones. These are called simple or single inequalities. The reason they're called that is because they only have one inequality sign. They have one greater than sign, or less than, or greater than, or less than or equal to. You still want to follow the same rules as far as how we start cleaning this up. For example, for this one, you're still going to distribute first. So you're going to have a -6x and then a +15 when you distribute that -3. You still want to combine like terms if they're on the same side of the inequality. So I'm going to have -6x plus 16 greater than or equal to 4. Then you want to subtract 16. So you have -6x greater than or equal to -12. And finally, you want to divide both sides by -6. And immediately there should be some sort of alarm going off in your head saying, I just divided by a negative. So that means my inequality needs to flip to a less than or equal to. If it has an equal to, it keeps it. If it doesn't, it stays without it. It's truly just that arrow thinking of is pointing the opposite direction. So now on my number line, I'm going to start at 2. I'm going to put a closed circle because 2 is included, and it is everything less than or equal to. For the next one, I have lots of distributing. Keep in mind, you're distributing the -3. You cannot subtract this 4 and a 3 because order of operations says you have to multiply before you subtract. So I'm going to distribute here. I'm going to distribute here. I love drawing arrows. So I'm going to have 4 minus 3x. -3 times -2 is 6, is less than 2x minus 20. And if you're getting to the point you're watching these videos and you're feeling really good about it, you are welcome to pause videos, try them on your own. And honestly, that's the best way to learn. See if you could do it without me explaining it. And then when you play it, you kind of go through mine really quick and you'll be able to catch your mistakes. I think that's the best way to actually learn math, is to try it before me, try different ones after me, and see if you're feeling comfortable. Then I'm going to add 20 to get the constants on this side. So I have 30 is less than 5x. Divide by 5. I'm not dividing by a negative, so I don't need to switch anything around. So here's my answer as far as like my form answer. My answer is 6 is less than x. I will say students often hate when the variable comes second. They would prefer to have the x come first. It is perfectly fine to rewrite it, but just keep in mind that the open piece is next to this x. That's not going to change. So if I want to rewrite it, I would actually rewrite it as x is greater than 6. That means the same as 6 is less than x. Sometimes it just helps people when they're drawing. So 6 is on my number line. I'm going to put an open circle and I'm going to draw to the right. Some special cases, and we'll see kind of what happens with this. With your always, sometimes, or never true, we're going to see a little bit of special cases. We're going to see some regular ones. So again, we're going to distribute negative 6x minus 2 is greater than negative 6x plus 7. What ends up happening here when I start getting all my x's on one side is my x's actually end up disappearing. So I would have negative 2 is greater than 7. If your variables are gone, meaning they completely cancel out, we have no variables on either side, what you're going to have left is something that's either going to make sense all the time or never. Negative 2 is never greater than 7. So you could leave the number line totally blank. You can write the word never, or you could write the symbol that I mentioned previously. This means no solution. There is no x value that I could plug in that would make that true. Now, if you had something, just kind of a side note, if you had something that was always true, so let's say you have negative 2 is less than 7. Let's say that ends up happening instead. This is a situation that is always true. Couple ways to write that. You could just write the word always. We actually also have a symbol for that. It's a symbol that I will use on and off this class. This is the symbol. It's called all real numbers. What this means is every number I would put into that inequality would make it true. So I could pick a 5, a 7, 8, a 10. Versus never means no matter what I pick, I could pick every number in existence and I would never get an answer. So looking at the second one, so when we distribute, we have 10x minus 15 minus 7. Combine my like terms. They're both negative, so a negative 15 and a negative 7 is a negative 22. That's a plus, really messy plus. Sorry about that. When I go to get my variables on both sides, or on one side, what you'll notice is they don't cancel. If my variables do not cancel, that means I'm not going to get a special case. I'm not going to get a never true. I'm not going to get an always true. I know right away before I even finish this one, it's going to be sometimes. Because sometimes my x values will work and sometimes they won't. I will finish it for you. So we're going to add 22 to the 8. So when I do that, I'm getting really messy. 7x is less than or equal to 30. Divide by 7. I didn't divide by a negative, so it just stays the same. I get 30 over 7. If you want to tell me what that is as a decimal, you can. Honestly, I think it's easier just to leave it as 30 over 7. These are values that are less than or equal to, so closed circle, heading left. So these are all basic inequalities. We call them simple or single inequalities because there's only one inequality. There are some special cases. You're always graphing them on a single number line and you're getting an array, basically. If you think about geometry, you're getting a starting point, whether it's open or closed, and then you're getting an arrow heading in one direction. I'm going to do another video that's just on the next type of inequalities, but I want to keep this all about the same one.